talk about the law of sines. So let us begin by assuming that we have the following triangle. If A, B, C is a triangle, so suppose you have a triangle, is a triangle with sides A and B and C. Suppose you have the following triangle. This is the triangle that we have with vertices A and B and C. And you have some sides. The side in front of angle A is denoted by A. The side in front of angle B is B, and the side in front of angle C is denoted by C. Law of sines says, well, A, side A, the length of A, divided by sine of angle A is equal to B divided by sine of angle B is equal to C over sine of angle C. Okay. This relation, this equality between these fractions is called the law of sines. Okay, so what is our conclusion? What do we get out of the equality between three fractions? Well, take a look at this. We conclude that, well, we have the following equalities. Since there are three fractions, you have A over sine of A. This guy, this fraction is always equal to B over sine of B. Okay. Also, A divided by sine of A is the same as C over sine of C. Very good. So far, so good. C over sine of C. What else? At the same time, you can set these two equal to each other, right? It means that B divided by sine of B is equal to C divided by sine of C. So these relations are called law of sine. Okay, very good. So keep this law in mind. So we go over some examples. Remember that we can flip all of these fractions. Sine A over A is equal to sine B over B is equal to sine C over C. So let me write a note, quick note for you here. Note that we can flip these fractions as well. So if you see something like this, if you see sine A divided by side A equal to sine B divided by side B equals to sine of angle C divided by side C. It's the same meaning as the fractions equality between fractions that you see here. So these two are equivalent to each other. Okay, very good. So you introduced the law of sines. Now tell me what's the use of these. Let's go over one example together. See how we can apply the law of sine and how it is helpful for us. Example. In this example, suppose a triangle is given. Let us have the following triangle. This triangle CAB, and the angle B is 29 degrees. Side B is 28. Angle C is 102. We don't have any information about side C. We do not know what A is, but we know that length A is denoted by A. Suppose this triangle is given to you. Let us have the following triangle. Question says, find the missing values. Very good. So what should I do? I have this triangle, and I just learned about the law of sines. Okay. So based on the information that is given to me, I know that these two sides are missing and angle A is also missing. If I set it up this way, what I have is A divided by sine A is equal to B divided by sine B. B is 28. 28 divided by sine of 29. Okay. So far, so good, which is equal to C. C is missing, divided by sine of 102. Sine 102 degrees. Okay, very good. We're going to do our best to find C, to find A, and also to calculate angle A. What you can do, you can just ignore the first fraction and then set these two fractions equal to each other. Then you can calculate C. So 28 divided by sine of 29 is equal to C divided by sine of 102. If you just multiply these two and divide by sine 29, C is 28 times sine 102 divided by 28. If you use your calculator, what you're going to get? You're going to get C, which is approximately 56.49. This is length C. So C becomes approximately 56.49. Very good. So I found length C. Now I want to know what A is. Well, as you know, angle A plus angle B plus angle C is 180 degrees. A is missing, B is 29, C is 102, and it is equal to 180 degrees. All right. Well, doing that, we can calculate angle A, which is equal to 49 degrees. Very good. So far we compute these. We know that C, the length C is 56.49. Angle A is 49 degrees. Now the last thing is left is A. Let's use these two. A over sine of 49 is equal to 28 divided by sine of 29. So my A is equal to 28 times sine of 49 degrees divided by sine of 29 degrees, which is approximately is 43.59. So we found all the missing values. That's how we use the law of sines.